Alright, so I've got these two die here, and what I'm trying to figure out is what's the probability of me tossing a certain number? And so what I want to do is I want to figure out the probability of tossing, say, an 11. Well, I know there's only two ways to toss an 11. That would be a 6 and a 5, or I could do a 6 and a 5. So either way, I have two ways to toss an 11. But what about if I was considering not tossing an 11? Figuring out the ways not to toss an 11. Well, sometimes you could do, okay, I could toss an 8 or a 7, or I could toss a 9, and you could try to figure out all the ways that there are to toss numbers that aren't 11. But what we're talking about today when we're talking about complement rules is taking the probability of tossing an 11 and saying that's the event that I don't want. And so if I go ahead and, whoops, dropped one. If I go ahead and calculate the probability of tossing the 11 and I subtract that from the total number of ways to roll the two die, that could help me figure out which way I could to toss not an 11. Okay? And so today's introduction has to do with figuring out the ways not to do something and how that can help us figure out the probability of actually doing at least or something else other than what we want. Okay? So let's talk about complementary rules today. Okay, welcome back. Today we're going to be talking about complementary events. When we're talking about complementary events, we're talking about things that could happen in conjunction with something else. If we consider rolling a die, okay, unlike in the introduction, we are just going to consider rolling one. Okay, so our sample space for the possible outcomes is going to be 1, 2, 3, 4, 5, or 6. The probability of tossing a 3. Well, the sample space is going to be 3. There's only one way to roll a 3 if we are considering rolling one die. Okay? And so the probability of doing that is going to be 1 out of 6. The complementary event to that is going to be the probability of tossing not a 3. Okay? So we are going to consider all the ways not to toss a 3. Well, if we think about that, that would be 1, 2, 4, 5, or 6. And so the probability of not tossing a 3 is going to be 5 ways out of the 6. Okay? How we would notate this. The probability of the complement, so the probability of the event would be to the C. This is the probability of the complement. Okay? So this is the probability of the complements, like the complementary event to something else happening. Okay? And so probability, I'll write it down here, is what else could happen. So the complement is what else could happen. So the complement to rolling a 3 is everything else that could happen. So 1, 2, 4, 5, or 6. Oftentimes, when calculating the complementary event, we're simply going to take the probability of everything happening and subtract something that has less possibilities. Let me show you how this works. Okay? What's the probability of tossing not 11 if the probability of tossing 11 is blank? Well, what we need to figure out is, out of rolling 2 die, okay, what is the probability of rolling that 11? Well, there's 2 out of 36 ways, or 1 out of 18 ways. Because if you think about the probability of rolling 11, there's only 2 ways to do it. Either you roll a 6 and a 5, or you roll a 5 and a 6. Well, that's 2 out of the 36 ways. So rolling not 11 is everything but 11. In this case, it's much easier to say we have 1 or 36 out of 36 ways to roll these die. Okay, so there's 6 times 6, which is 36 different outcomes for these die, right? But instead of saying what's the probability, how many ways are there to roll a 2? How many ways are there to roll a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, an 11, and a 12? Okay? That's all the ways there are to roll these die. But what we're saying is take all of the events and subtract, so 36 out of 36 minus 2 out of 36. That's rolling the 11. And what we end up with is 34 out of 36, or 17 out of 18 ways to roll not an 11. Because there's only 2 ways to roll an 11, so every other way must be rolling not an 11. Okay? And so that's a complementary event. The complementary event is the ways not to roll what we want, okay? Or to roll what we want, which would be not an 11, okay? So in B, let's think about this. I'll use red because it's blood type. The probability of a person having type A blood is 34%. What's the probability that they do not have type A blood? Well, there's a 100% chance that they have blood. So that's the 1. So the 1, remember we talked about in probability, is the event that something happens. Well, 1, they have blood. And we're going to subtract the probability that they do not, that they have type A blood. So 34%. Well, really what this is saying is 100% chance that they have blood minus 34% chance that they have type A. And what's left over is everything else. So there's a 66% chance that they do not have type A, because we subtracted the chance that they do have type A. Okay, so instead of considering type B, type O, type AB, type A negative, type B negative, type, all of those possibilities, we said just take away what you want and whatever's left is what you are looking for. That brings us to the topic of at least one. At least one is saying we don't have none, because we could have 1, we could have 2, we could have 3, and depending on the event, we could have 4, 5, 6. It's everything else except none. And so the probability of rolling it or flipping at least one head in 3 tossed coins is going to look like this. Let's look at the sample space. The sample space is heads, 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 tails, heads, tails, heads, tails, heads, heads. And we know that we have 8 possible outcomes because it's 3 flips of a coin. We have 2 possibilities in each type, so we have 8 possibilities. I have 4 of them outlined so far. So let's think. We could have heads, tails, tails. We could have tails, heads, tails. We could have tails, tails, heads. What am I at now? 1, 2, 3, 4, 5, 6, 7. So the last one must be tails, tails, tails. Well, we listed all these out, but let's think about this logically for a minute. At least one means not 0. So not none heads or not no heads. So we would take 1 is the probability of getting 3 coins flipped. So 1 is going to be all of the possibilities. Well, what we're going to do is we're going to subtract the probability that 0 heads show. So that's going to be 1 minus 1 out of 8, because 1 out of 8 is the number of ways that no heads show. So that would be tails, tails, tails. So that's this one right here. Okay, so we have a 7 out of 8 chance that 1 or more tails show. Sorry, heads show. Or at least one. Because think about it. We have at least one here, we have at least one here, at least one, at least one, at least one, at least one, at least one. So we subtracted all the possibilities that there were none showing, and we came up with 7 out of 8. Yes, we did all the work this time, but next time we're going to know that we can subtract the possibility that none happened. and we'll be able to figure it out instead of listing all these out. Okay? Let's think about this logically again. The event. The die is tossed 4 times. What is the probability of at least 1 6 showing up? Okay? So the event is at least 1 6. The complement here is no 6s showing. Okay? And so what we're going to say is the sample space is going to be all of the possibilities. Okay? So if we're tossing 4 die, we need to outline our number of total possibilities. Well, the number of total possibilities for the first die roll is 6. And in each subsequent roll, we have 6 possibilities. And so when we actually do the math here, we have 1,296 outcomes. That's all of the possible outcomes. The complement is that no 6s show. So what we are going to do is take out the possibility for a 6. And so what we're going to say is, in 4 tosses of this die, how many possibilities do we have? Well, we're going to take out the possibility that 6 could happen, because what we're calculating is everything else except 6. Okay? So what we're going to say is, we only have 5 possibilities, because we're going to say that 6 is not a possibility. It is. But when we're doing this calculation, we're saying how many ways are there to roll not a 6. And so in these 4 subsequent rolls, we only have 5 possibilities. 1, 2, 3, 4, or 5. Because we're taking out the possibility that 6 happens. And so when we do this, we end up with 625 outcomes without a 6. Okay? And so what we are going to do is we're going to say we have 1 minus the possibility that there is no 6. Okay, so this is the possibilities without a 6. And because this is probability, it's a fraction. This is the number of total outcomes there are in those phases. This is the number of outcomes of those that do not have a 6 in them. And so when I do this math, I get 671 out of 1,296. This is the number of ways that at least 1 6. So there's 1, 2, 3, or 4 6s showing. Okay? And that's approximately equal to 0.518, or 51.8% chance of rolling at least 1 6 in 4 tosses. Okay? I'd like for you to take that and figure out this one. Do the math and figure out how many ways in 3 times, what is the probability that a sum of 7 comes up at least once. Look back to the previous example and see if you can figure this one out on your own. Okay? Alright guys, thanks for watching. We'll catch up with you next time. And if you have any questions, be sure to come see me.